Hello, everyone. This is Antika, and
Eric Almanzalera.
so our team is DataNoles, and we did a project on topic query processing and optimization. So, in recent technological scenarios, there seems to be a constant overhead of query time processing. So, with a large amount of data, it takes a considerable amount of time to generate the results. This led to the development of topic queries, which focuses on generating the most relevant results according to the users. So, the main objective is to rank the objects and return the K results with the highest scores. There are a lot of algorithms like the threshold algorithm, approximation algorithm, which have been developed on top K queries. Queries have a significant advantage in fields like e-commerce, multimedia, web search, and are mostly helpful when working with large amount of data sets. The top K objects are usually identified by scoring objects based on a particular function, where the score depends on the characteristics of the object. So the solution that we got is inspired from the Being Picky paper. The which talks about the top K with set defined selections. So what is set defined selections? We can say that it's the selection of points from a certain subset. This also helps optimizing the query runtime. So from this image, this picture is a sample of top K query with set defined selections. For this project, we have implemented a cost model, and we have also implemented the combined index, which we will discuss later. For the estimations, we have first we there are three algorithms that we have like implemented, and we have implemented a cost model for both the ID ordered and the score ordered indexing. So in the case of ID ordered, we have implemented this equation where we calculated the dB, which is the size of the data read from the disk, and we did the same for score ordered indexing. And then we calculated the query runtime, which is t equal to c1 plus c2 into db, where c1 and c2 are the constants. And we have also implemented the combined index. So the combined index is something which is an index which actually chooses the best of the two indices and saves a lot of time and helps in efficient query processing. So now I would like Eric to give a quick demo of the project.
Okay, will do. So we'll begin by taking a look at the tables that we used. So in our project implementation, we did one table for each indexing type. So for the first type, the ID index, we chose the song number to be our ID index since it's a unique identifying attribute. And this index is in the structure of a B tree. And now for our cost index, we chose, or actually our score index. So for our scoring index, we chose duration as our attribute to score on. And it is also in the structure of a B tree as noted here. So we basically use two tables and one for each index type, which is ID and score. So now looking at our Java files, you can see that we have one Java file for estimating the ID equation, and then the other file estimates the score index equations. All right, so looking at our files, we have one file that estimates the query runtime of an ID index, and the other estimates the query runtime of a score ordered index. And this estimates the queries of set defined selections as Antika previously described. So our main program is used to estimate the query time for given set defined selections with different cardinalities from 2 to 500. So we basically create top K set defined selection sizes, or top 20 set defined selection queries from sizes 2 to 500. And for each of these queries, we estimate the time using our equation files. And then the equation file that provides the least amount of runtime is chosen as the index type. So for example, if we're estimating a query on ID equation and score equation, and ID equation comes out with the least amount of time, the ID index will be chosen as the index to actually run our query. And our program basically runs this on various sizes of, or various cardinalities of set defined selections. So here we will run our main file. So as we can see, it is running top K set defined selections where K equals 20. We got this idea from the being picky paper. They used K equals to 20 as well. And now that our execution is complete, we can go ahead and graph our results. So this might be a better one to do first. So here's the results of our main Java file. So here we could see the ID, score ordered, and combined index all into one. We could see that it follows the trend of the combined index slightly. Right now, since I'm running multiple applications and recording, there's a lot more peaks and there's a lot more fluctuation in the time, in the query execution times. But so here's our results. As we've said before, because there's multiple applications running on this computer while it's recording, it's a little more fluctuated in the actual query execution. But generally, it will look similar to this. It'll follow basically this combined index estimation. So it'll choose the lowest amount, or the ID that provides the lowest execution time, and it'll follow this trend. And yeah, it just follows it more closely. And now I'll pass it back over to Antika for discoveries.
Yeah. So I would like to conclude by saying that the system described in Being Picky leads to much more efficient processing time for set-defined top K queries. Being Picky does this by estimating the best indices that helps in quicker processing or efficient processing. In this project, we have addressed the implementation of top K query with set-defined selections. As we know that top K query has been a wide research area in the database systems, and this is actually one of the novel approaches for computing it. We have implemented the mathematical model of this paper by calculating the combined index. Thus, we can say that through combined indexing, the best of the two indices with smaller execution time is chosen, which definitely saves or reduces the query runtime or saves a certain amount of time. However, this system still has great potential for expansion, whether it is about adopting new algorithms into its decision process or implementing this system to perform for multiple tables. Being Picky definitely has an impactful feature. Thank you.
Thank you.